So here we're back at our Lifeguard code. This time around I've added a velocity to the swimmer. So the swimmers are going to be drifting out at 0.5 meters per second to the right and 0.5 meters per second up. And of course that's away from the Lifeguard. So we've just added a little update for the swimmer's position in both of our loops. The Lifeguard is still going to continue until he finds the swimmer. But this time we've got to continuously update the angle that the Lifeguard travels at. So we've copied and pasted this velocity angle calculation down to here. What we're going to see is that it takes the Lifeguard much longer to catch the swimmer this time. I've kept the transition x at our magic value before of 1.55. I've made the field a little bit bigger so that they don't go off into the abyss. So there it took about 3¼ seconds compared to less than 2 seconds that we had last time. Just like before, we've got the Lifeguard going to the cutoff point, but then we don't have the Lifeguard traveling at in a constant direction. At first, we start heading off in that original angle we had, then the Lifeguard's trajectory curves just a little bit. You can see that especially when you compare it to the green trajectory here. And so what I want to take a look at in this video is whether this special location of 1.55 still produces the minimum amount of time for the Lifeguard to rescue the swimmer. Obviously, this is a more complicated problem now because we've got 2 additional parameters to worry about, the swimmer's x and y velocities. We're going to leave all that constant just to see how much the transition point changes by that we should be heading towards. So we need to set up another loop, only this time we've got to include both the Lifeguard and the swimmer in our loop because I don't want the swimmer resuming his course up here and just starting it farther away from the Lifeguard. I want the swimmer to restart back here each time. So we're going to start with our for transition x in range. We're going to do the same way we had it before. Let's start with a 1.0 instead of going to the middle like we did last time. Let's start with a 1.0 and let's go out to, let's make it all the way out to 3.0, just since the swimmer is moving away from that original position of 2¼ and let's have this change by a factor of 0.2. And so I've set up my loop here, so now I just have to take all of this and encase it in the loop. We'll hit tab. So I just have to add our output here of transition underscore x, comma transition underscore x. Give that an equal sign just so I understand this is what I'm talking about. Let me make sure that I've got my, yes, I have called that the correct name. And so this is going to reset every time the Lifeguard catches the swimmer. And I think we can increase our rate here. Let's bump that up to maybe 200 just because this is going to take a little bit longer than the last time. I think our DT ought to be fine. All right, let's hit Control 2 to run. Okay, so we definitely are going to be able to capture the minimum because we started at 3.34. We're now at 3.255. So let's let this Lifeguard continue running laps here and see what minimum time we get. Okay, so we've gone from transition x equals 1 to transition x equals 2.8. That's right, it doesn't do the doesn't count the ending value, but we definitely have captured the minimum in this range because we start out at 3.34 here, and we end at 3.31, and in the middle we get down to 3.23, looks like the minimum, and that's definitely not at 1.55. So 1.55 was left behind back here. So it's actually more advantageous to go a little bit farther along the beach, which makes sense because we are going to have to spend more time in the water, so we need to make up for that by spending a little more time on the beach. Let's refine our window here. So let's go from a transition x of 1.8 to 2.2. So let's go up here. We want to go from 1.8 to 2.2, and let's decrease this now to 0.05. I think I'm happy with the number of decimal places on the time here. We're getting out to the 3rd decimal place, so that ought to be fine, but I want to get more decimal places out here. Actually, why don't we increase this to 0.02, and we'll increase our rate to 500 since I think we're going to end up with more data points here. Okay, it looks like I probably would actually benefit from more decimal places on the time there, but it looks like 2 is going to be our winner because we've got 3.235, 3.235, and this one's just 3.23. So let's narrow the window even further. Let's go from 1.96 to 2.04. 1.96 to 2.04, and let's see. I'm happy with the number of decimal places there. Actually, let's decrease that by half. There we go. Let's get that down to 0.01. And I want to decrease my dt here. Let's get that down to 0.00. Let's make it 0.2. And then we'll increase our rate yet again. Control 2 to run. Okay, so it looks like 2 is still approximately our winner. 2 and 2.01 come out to be the same as far as the decimal points we're looking at here. I mean, we're talking about a centimeter there. So you know, we're literally splitting hairs at that point. We're splitting sand grains at that point. Oh no, actually, excuse me, I'm wrong. This is less than that. 3.2318 is a little bit less than that. I actually need to let this run out a little bit farther. Excuse me. I must have misread my original results. Let's make that 2.15. Control 2 to run. Okay, yeah. So our minimum is out here somewhere. Oh my, actually we go back down, don't we? That's interesting. So this is actually not, this might not have just one minimum. Because if I look over here, I go from 3.2318 back up to 3.232, then back down to 3.2318, then back up to 3.232. This thing actually might have two minima associated with it. It's pretty cool. But again, this is all within, you know, a few centimeters. So, you know, we're splitting hairs. So for the purpose of the problem, we're learning that we want to go out just a little bit farther than we would for a stationary swimmer. But yeah, interestingly enough, there's a couple of minima in there. That would be interesting to explore. Well, either way, the main lesson is still the same, that you do want to aim to have a little more distance on the beach and a little bit less distance on the water. That same general rule still applies. Of course, you can play around with this a little bit more. You can have the swimmer moving up and to the left. You can have them moving in any of the four major directions there, which I think is pretty cool. So this has been a fun little project to work on. It's been a nice little break over the summer, work on something a little bit simpler. Feel free to take this code as always and play around with it. Let me know if you get any interesting results. If you find out what's causing those two minima, that would be really interesting to hear about. Thank you so much for watching. I will see you next time. Bye-bye.